Okay, so hopefully um, you all are on the Creo opening screen. So Creo is a little bit weird. Unlike any other program you've ever used in your entire life, you have to choose where you want to save your files before you make a file. So we're going to go ahead and select our working directory. Yeah, documents is fine. I'll create a new folder. We'll just call it Crash Course Blade. And so once you pick whatever folder you want, you press OK. And this is where all of the things we do for the entire time we have Creo open now, that's where they're going to be saved to by default. If you don't do that, you won't be able to get like past versions of your file. So then we're going to go ahead and create a new part. And since we're going to deal with some 3D part, we'll make sure it's actually a solid part file. So part that's solid. We'll name it the blade. And we're going to uncheck the default template just so you can see what's on the next screen when I press OK. And so basically here is when you're going to pick your unit system, essentially. So by default, it's in inch pounds for solid parts. If we wanted to change to metric, we could go down to millimeter Newton second for solid parts, but we can stick to inches just because it's what everyone knows from here. We press OK. And once it's done, you'll see this is the start to creating a part. So you have your 3 different planes at your origin that you can use to create your sketches on. You have your right plane, your top plane, and your front plane, right? So those are the 3 different views. You can look at an object, right? Your top of an object, front of the object, side. And so with that, that's how we're going to go ahead and create the part. So if we look at our image, we kind of have, maybe you could call it some sort of like exaggerated J shape is essentially what we're going for here. And so there are a couple different ways we can do that. I guess what I can do is showcase a couple different ways depending on basically how much you know about the part. So the first way, we're going to just go ahead on that front plane. We'll pre-select it and press either sketch up here at the top, or you see when we select it, there's like a little pop-up window. We can press sketch here. And then on this sort of mini toolbar, we go to sketch view so we can see a straight on view. So we can basically sketch in 2D here. In order to drag and pan around, hold shift and click the middle mouse button, right? So you can shift your window around. And so we're going to go ahead and create that sort of like J shape. It'll be super rough at first, and then we can go ahead and add dimensions to it later. So probably the easiest place to start is up at the top. So right, it has a little bit of a straight piece there near the top. So we can go ahead and create our U. And unfortunately, Creo is super annoying. And if you don't dimension, like if you create your whole sketch and then dimension something, it'll keep all of the fake dimensions it created. So the easiest way to do that, to like get your scaling right, is to draw some known line and then sketch stuff out later. So here we'll just, for pretend, say this is 6 inches, right? And you see how it kept this 18. It doesn't keep the same scaling that it was. And we'll say that it's, an inch apart. Right, so you can kind of see that this is like the side view of the top portion of that Cheetah blade. So the piece that would attach to what's attaching to the nub, right, if that makes sense. And so from here, we can go and do more of a rough sketch now that we have Creo has sort of a general sense of our scale. So we add dimensions later, it's not gonna yell at us, essentially. So we can go ahead and create our arcs, right? So something like that would be maybe our first arc, and there's probably some sort of compound arc in there. So we can create some sort of second arc, right? So we have one there and one there. And I'm going to pause and let anyone who's working on it. All right, so the next thing that's probably like the only other dimension we would know in this case is probably this like top to bottom dimension. Right, we would know how big this thing is. So we can go over here to our dimension tool. We can click this top point, and what's going to be, yeah, that'll be our bottom point. Click the 2, middle mouse button, click somewhere between them vertically, and you'll get this dimension. If you don't click between them vertically, you would get that dimension, which is not what we're looking for. It's important that it needs to be between them top to bottom, not between them left to right. And we'll say it's something like 20 inches. That seems somewhat reasonable. And so now, right, the other thing that's important is that this needs to sort of be the lowest point on the blade. And so what we'll do is we'll create a center line here. That'll be horizontal at the end of this. So what this allows us to do is once we have that horizontal center line 20 inches from our top, we can go to our constraints, and we have the tangent constraint. And so we can go ahead and click these two curves, or this curve and this line, and make it tangent to each other. Right, so now this looks more like how we expect this to look. Yep, that's what I thought I was going to do. Yep. Cool. All right, so the other thing to me that I'm looking at now is sort of this curve that sort of bends backwards a bit. And so, right, we can see we're sort of accomplishing that by how far left or right we drag the end of this first curve. Right, and we can change, up and down kind of how it looks. So to me, I'm going to say that the easiest way to do that, and just to use another constraint type, is there's this coincident constraint, which allows you to basically pick 2 points or 2 lines, and they are going to merge together, right? So now this point is always going to be on this vertical line. So we can only drag it up and down now. And so now, right, with more rigid designs, right, we would have all the dimensions, right? We would know everything. But for our purposes, right, especially when dealing with animals, we kind of have close enough is about the best we can get, right? You can't force an animal to sit down and take every measurement you could possibly want. It's just not going to happen. They're going to be moving. You're going to get, as close as you can get to what you want. And so here we can kind of decide, how we want this to look by eye, right? We can always come back and change it, right? That's what's great about parametric modeling, right? When we're done with this whole thing, we could decide that actually we hate everything we did, and that's okay, right? We can come back, and drag this up, and maybe we think that'll be better. I think this looks somewhat reasonable to me. If you want, you could plug in numbers, right? I could make this 23. I could make that 5, right? And I can fix the whole thing a little bit more. Right, so I'll give you guys a little bit to play. All right, so the next, there are a couple ways to do the next part. We'll do maybe what's the easiest. So we'll go back to this arc tool, right, the 3 points, and we're going to create another arc, and then that we just create our 2 arcs, right? That's fine. And so what we're going to do is we're going to come up to our constraints here again, and these 2 horizontal lines is our equal constraint. And so we'll click our first arc and our second, and now they become the same arc. And then where did...
Would we be able to use the offset tools?
Yes, you could. Absolutely. And let me see if I'm doing this. All right, that's way weirder than I thought it was going to be. Never mind, offset's easier. That's odd. All right, so we'll click the offset. We'll click, we can do single, that's fine. And we type in -1, just because we have the arrow the wrong way. And it'll have it here. Yeah, sometimes it does that. So what we can do is we can go to, where is it? Oh, it might not exist. We can see if we could coincident them. Yeah, that'll be fine. And we'll do the same thing. We'll offset this one by -1. And coincident them. We'll draw a line here at the end to complete the shape. Now that it turned pink, it means we have a complete shape, like all the perimeter of it is done. It doesn't seem to be yelling at me for any reason. Oh, this one is still 1 dimension we could do. Of course. I think this is going to make, yeah, okay. This constraint will help it. Nope. We'll do a vertical constraint on, really, I can't get points either. Fine, it'll just be the dimension it wants to be. For some reason, it's wanting this point to be independent of everything else. And I'm not quite sure why I can't constrain it properly. But there, right, so this kind of looks like our side profile, right, from this one, image. It's not too bad. So just again, we use the offset tool. We click the arc we had. We typed in -1 just because that's our thickness up here. And then when that created some, smaller version of our arc, we used the coincident constraint, and we took one end of it and we attached it to our free hanging vertical line over here, just so we can get one continuous shape. We did the same thing for this bottom arc. We connected it to the end here, and then drew a vertical line to connect these 2 points. We'll go ahead and we'll press the big green check mark, which says we are done with this sketch. And then we will press Control D once we're here, and this gets us back to our default view, right? Our 3D view of it, essentially. And so over on the left, we're going to pre-select our sketch, right? We'll click it. And then either you can do the extrude button, you can use the shortcut, you can press the extrude button up here, whatever you're fancy. We're going to go ahead and extrude it, not 18 inches, that's sort of insane. Let's do like 5. Right, and so now we have what kind of sort of looks. All right, let's see if I can get the angle right. I mean, it's not bad. Okay, so we'll go back to the default view. So a couple other things, right, we can notice is first, most glaringly, right, there's this sort of round here at the end. So that's quite simple, right? We can go to a round tool. I don't know, maybe it's like 2. Right, we'll click this curve. We'll click the back curve. We can easily go ahead and add our round in. One somewhat annoying thing is you see how I click 2 curves? If I change this number now, it only changes the second one. In order to change them both, you have to change it in here, I think. So this will change both. No, it'll only change one. You have to do it twice. Because for some reason they're different sets. Again, I don't know. The other thing I see, right, is the front of this is also a bit rounded. So we can do that. Again, probably even the same dimension. Nah, I don't like that as much. One's good enough there. And sure, if you want to go crazy, you can even sort of round these edges, right? Something small, like I don't know, 1/8 of an inch. And we can sort of round the whole deal. Right, and just to get rid of the sharp edges on the end. Any questions with the round tool? As my absolute favorite professor of all time would say, I'll take that silence to mean no problems. All right, so the next thing, right, is clearly it needs some sort of way to attach, right? And so we're going to go ahead and create some holes on here, and we're going to do that with the hole tool. We could do it with an extrude, and we could cut it with some circles, and that would be fine. But because, as you see, we're putting bolts in there, we can use Creo's built-in information to know how big these holes need to be for certain size bolts. We could even, if we wanted to, make it a threaded hole through this, that it would have the right threads and it would make it the right diameter to actually produce the thing. So put a hole, we'll click this face, and you see we get these 2 little red handles. So we'll drag one to this top face, one to this face on the left. And so you see, once we did that, we got extra dimensions, right? We have this 1 up here. We have this whatever guy up here. So we made it 5 inches across. So we'll make that. So we get it halfway, right? Okay, so then what we're going to do is we are going to create a standard hole. And we're going to make it a clearance hole. So we'll unselect this add tapping and make it a clearance hole. So this thread type is, how is it the thread defined? So it's possible in some of your classes you've come across bolts. I don't know if any of you are MEs. Actually, I don't think so. And so bolts are defined either through the international standard or through like the US standard, right? So your US is going to give you things like this is a 1/4 inch bolt with 20 threads per inch. Don't worry about these numbers ones. They are just arbitrary numbers like you would expect the imperial system to do. Right, so this is 7/16 inch diameter and 14 threads per inch. In the ISO, you're going to get it with metric, right? So this is a 2 millimeter diameter hole with 0.4 threads per millimeter. Actually, it might be per centimeter. I think it's per centimeter. Yeah. So because everything we did was in American units, we'll use one of the Americans. So this is fine threads versus coarse threads. So for each bolt size, there's 2 different thread types, right? One is going to have more densely packed threads. One is going to have more coarse threads, right? We'll just do the coarse because that's sort of the default. And whatever. Yeah, we'll do the standard, like 1/4 20 is fine. So this is our end condition. So this is drill up to next surface, drill through all surfaces, right? We can pick the surface if we want, right? Selecting the back one. Oops. And then this gives us options to add like a countersink or counterbore if we wanted to, right? So we could look at that. And because it knows what bolt we picked, all of these things are by default. Whereas normally we would have to look up, go on the internet, find all of our tables, right, and deal with that. But all of these programs have the default threads built in because they're used all the time. Why not just have it in the database? All right, so that is what our hole looks like, right? And so we have our 1/4 inch diameter hole with 20 threads per inch. This 2B is indicating the precision and the direction of the threads. So B threads are internal threads, A threads are external threads. And then that's just like, these are important things for when you go ahead and make the drawing and then you send it to a machine shop so that the guy who does it knows, what's going on. Any questions on holes? And I will let anyone catch up because I know that was a lot of information I threw at you. Everyone has this hole. The next thing we're going to do is, maybe it's not strictly necessary, but it's a nice feature to show off. So we're going to go ahead and select this hole on the left on our model tree. And when you do, you'll notice that this pattern lights up, right? So when I unselect it, it's not there, but now I have the purple. So we're going to go ahead and select on the drop-down geometric pattern. And so this allows us to basically create a pattern of our feature, right? So the first thing it wants us to do is to select our direction. And so we will select this, any sort of vertical line will do it, right? So I'll select that one. It wants to do it up. I don't want it to go up, so I flip it. We'll say, just for the sake of this, maybe I want 3. And the spacing between it, let's say, is going to be 2 inches. Maybe 1.5. Yeah. If we want, we could create this to be a whole, like, a whole set of rectangles, right? So we click this box to select our second direction, right? We could create a whole separate spacing. Yeah, don't worry about that. So we could also make it a circular pattern with this. We could make it a pattern on a curve. So if we had in a previous sketch drawn some complex curve that we wanted a hole every 1 inch along, right? That's really hard to do. But if we create a curve pattern, you could pretty easily make that feature every 1 inch along some, winding curve. And there we go. That's one way to make a Cheetah blade. If you're familiar with other programs, this could also very easily be done with a sweep, right? So we create one line that we're going to, we're going to trace with, just a square profile. You could also do it with making a sketch that's the same thing we did, and it's extruding it left and right as a surface, and then thickening the surface. Yeah. But this is, I think, probably the easiest and most straightforward way to go about it.